now we have this thread and screws. So this is a screw, and it has a wrench attached to it. And the way screws work is every turn of the screw will move it up one thread. So you can see these threads are getting, more and more threads are appearing above the nut as it gets turned. So this is what raises it. So now you do one big circle with your finger, the effort force, and you just move up one little thread. So that's what gives screws a large mechanical advantage. So if we go through in this problem here, there's a way to distinguish threads. Threads are labeled with two numbers. The first number is the diameter, how thick the whole screw is. The second number is called the threads per inch, and that's how many threads are in 1 inch. So here there's 8 threads per inch, which would mean that each thread, the distance between each thread, would be 1/8 of an inch. So if you read through these bullet points and make sure you write them in your notebook, because these are the things you got to remember, this will let you understand how threads work. So we're going to use the circumference of the circle made by the wrench as you put your finger around to be the effort distance. So you can see here that when this wrench is going around, that his finger is actually moving in a circle here. And that circle is going to be our effort distance. And when you do that, you go up one thread. So the load will go up one thread for every circle you do with the wrench. If we look at this thread here, it's a 1-8, which means it's a 1 inch diameter, and there's 8 threads per inch, and that's what we're going to need to find the load distance. So if we draw a diagram of this machine here, these ones always get a little tricky here. I like to show the threads of the screw, and then on here we have a wrench, and this wrench is going in some sort of circle. Alright, so this is our effort distance, is all the way around the circle. Open and attached to the thread is the 25 pounds. So that's the effort distance, is all the way around the circle. And then our load distance is just going to be one thread here. So that one thread is the load distance. All the way around the circle is our effort distance. And then we have our load forces is going to be the weight, as usual. So the load force is being pulled up. That's the load. And the effort force is being pushed around the circle. So that's our effort force. Alright, and as we go through these problems here, you should be able to pick these up one by one. So measure the length of the wrench to the nearest 1/4 of an inch. So when you look at this wrench here, the center's right here that we're measuring from. So we got the center right here, and we're measuring out to, looks like we do the nearest 1/4 inch, it's right that line there. So you have to read that off the ruler, and then you're going to use that measurement to calculate the effort distance. So we need to find the effort distance all the way around. So since this circle is going around here like this length is not the diameter, this length is the radius. So when we have this formula here, when we're trying to find the effort distance, we're going to use the formula, so it's going to be 2 pi times the radius. And this radius here, this length that we're measuring, that is the radius we're going to use, because this length is the radius of the circle that's made by the wrench as it moves around. So we'll find the effort distance there, and then we find the load distance we know from the threads per inch, and then you can find the ideal mechanical advantage. The last part here is we need to find the actual mechanical advantage, and to do that you're going to need to read off this value on the wrench, on the scale as we're going around. So if you look at this here, it's 12.2, 12, 12.4, 12.6, 12.8, 12.6. We need to read this off to the nearest ½ pound. And so hopefully when you look at that, estimate the effort force nearest ½ pound. It's either going to be 12, 12.5, or 13. And you pick out which one you think it's closest to. And then once you do that, you can find the AMA and efficiency.